Hello, welcome to Chapter 1 PowerPoint presentation, the Introduction to Hydronic Heating and Cooling. We will be discussing what is comfort heating and cooling, the evolution of heating systems throughout time, and hydronic system advantages and also their layout. We will be defining what a hydronic system is. We will also be discussing the earliest methods used to heat and cool living spaces and see how they have evolved into the different types of heating and cooling hydronic systems that we have today. We will also be going over the advantages of using a modern day hydronic heating and cooling system and also breaking down the typical hydronic heating and cooling system into three main parts. Let's start with defining what a hydronic system is. A hydronic system is a heating and or cooling system that uses water or another fluid as a heat transfer medium to move heat from one area to another. Hydronic systems can be used in residential, commercial, and industrial buildings. The object of any building heating or cooling system, including a hydronic system, is to provide the maximum human comfort possible. One of the earliest methods used by humans of heating and living spaces were open fires. This early use of fire consisted of centrally located fires in the open space and in caves with openings to remove smoke. Techniques were used by humans to harness solar radiant energy from the sun. For instance, the sun energy would be used to heat water, bake bricks to create strong building materials, and to dry foods for preservation. Early cave dwellers preferred caves with openings facing southeast to allow the morning sun to warm them. Ancient Greeks built houses to take advantage of the sun's rays during moderately cool winters and to avoid the sun's heat during the summers. The Roman Empire applied solar energy technology by adapting home building design to different climates, using glass to enhance the effectiveness of solar heating and include solar conscious design with greenhouses and public baths. Between 300 BC and 10 BC, hundreds of baths were built throughout the Roman Empire using a system called hypocausts. The hypocaust was a system utilizing a raised floor set on a stack of tiles called a pile. Hot air from the adjacent furnaces were directed into the hypocaust space, heating the stone piles and the underfloor, which would transfer heat by radiation to the room above. The advancement of metal castings led to the development of cast iron firebacks to protect a fireplace. The grate, the raised grate was invented by Louis Savot in the late 1600s, France. Its hollow bottom and back allowed the room air to circulate through the bottom and out the top of the mantel. Stoves first appeared around the 1800s or 800s, mostly made of stone or clay brick. By the 1400s, they were made of cast iron. The potbelly stove gained prominence and was used for space heating well into the 1900s. Boiler use and steam heating became the next improvement in heating building spaces. The boiler was envisioned as early as 120 BC. Hero of Alexandria produced the first steam turbine by heating water in a closed vessel. However, the greatest impact of the use of steam did not occur until the Industrial Revolution by the 18th century and early 19th century. James Watt of Scotland is credited with the development of the first reciprocating steam engine in 1736. The new engine was able to provide the reliable power required by emerging industrial machinery. The production of steam for power generation led to the idea of also using steam for heating purposes. The first cast iron radiator was invented in 1874 by Nelson Bundy. By the late 1800s, cast iron sectional radiators were in widespread use. Industrial and commercial use of steam heating is still common today. Hot water or wet heating systems developed based on the steam heating systems became more popular, and heating systems for residents and light commercial buildings. We will be discussing some different types of hydronic heating systems. A gravity hydronic system is a hydronic system in which circulation to the heating units is accomplished by the difference in density of water in the supply and return mains. As we can see on the diagram, right, the hot water has a lower density and rises as it hits the thermal units and it gives off its heat. The cool water has a higher density and sinks back into the boiler. As you can see on top, the expansion tank is also there, which is open to atmosphere. Gravity flow systems commonly employed low temperature of boiler water. Because of this, thermal units and connecting pipes must be sized relatively large to meet the calculated heat loss of the building. The response to changes in outside weather conditions is slow. With the open hydronic system, a hydronic system that is, at some point, open to atmosphere. In these early systems, piping was routed from the boiler to the thermal units using risers and upwardly graded piping. At the top of the system, an open overflow pipe was connected to an expansion tank that provided for thermal expansion. A return pipe conveyed water back to the boiler. As temperature and limiting controls were developed, these systems became more popular. A closed hydronic system is a hydronic system that is not open to atmosphere. The development of electrical pumps significantly improved the efficiency of hydronic water circulation. Radiant panel heating systems have been introduced to North America by architect Frank Lloyd Wright in the 1940s. However, these systems faced increasing competition from central air conditioning systems and fell out of use. As we talk about early hydronic cooling techniques compared to the cooling systems we use in modern day, we can look back and see how in the earliest forms, the ancient Egyptians used forms of evaporating cooling by hanging reeds in the window spaces and running water down them to allow natural breeze to bring cooling mist into the room. The Romans took this a bit further and routed cool water from the aqueduct systems through walls to cool the masonry walls and thus in the interior of the rooms. The Persians used tall structures called wind towers to capture the wind and funnel it down the interior channels of the tower to create cool flowing air in living spaces. The availability of electricity led to the development of the electric fan in the late 1800s. In 1924, a new efficient centrifugal compressor was installed in an air conditioning system in the J.L. Hudson department store in Detroit, Michigan. In 1929, Frigidaire introduced the first commercially successful room cooler. Freon, a refrigerant safer than ammonia, was developed in the 1930s and increased innovation in the refrigeration air conditioning. The development of smaller refrigeration-based cooling systems and the availability of cheap electricity and gas have led to the popularity of forced air central heating and cooling systems for residential and light commercial use. In these systems, air is heated in the furnace or cooled by the air conditioning unit. The system in modern-day hydronics heating and cooling, it is widely used for comfort heating and cooling in commercial and industrial spaces. The development of chillers allowed for the practical use of chilled water as a cooling medium. The development of small refrigeration systems had led to the wide variety of smaller chillers suitable for residential use. For best comfort, a heating system must keep body loss within the correct proportions using radiation, convection, and conduction. Since the greatest amount of body heat is lost by radiation, it is logical that the system that most satisfactorily controls this loss is best able to create a comfort condition. Hydronic heating does exactly this because the thermal units most effectively warm a space's interior surfaces. The temperature of the supplied heat transfer fluid from the boiler to is sometimes controlled automatically according to the outside temperature using a master sub-master control system. Hydronic heating systems must have enough capacity to provide heat transfer fluid that is warm enough to adequately heat a conditioned space on the coldest design day. A hydronic system maintains a steadier, more uniform temperature in a home. Some other benefits of hydronic heating is that for a given temperature rise, liquids can absorb almost 3,500 times more heat than the same amount of volume of air. Therefore, far less water than air is needed to distribute the same amount of heat, meaning that hydronic water distribution can use piping that is much smaller than the equivalent of air duct work. Hydronic systems cost less to operate and maintain because of the durability and long life of the equipment. In both winter and summer, domestic water can be heated using the same boiler that supplies hydronic systems. The three ways this can be done is a combination boiler with an additional heat exchanger or with an indirect fire water heater installed in the boiler. When talking about the three main parts of a typical hydronic water heating and cooling system, the typical modern hydronic heating and cooling system is divided into three main parts: the heating and cooling sources, the distribution system, and the thermal units. Each of these are normally installed in different areas of the building: the mechanical room, hallway ceilings, and other out-of-sight building areas, and the building spaces or rooms respectively. The mechanical room is where the mechanical equipment and the electrical systems needed to run that equipment are located. The boiler and chillers may be large units, and there are maybe several large pumps that also require a lot of space. Hallway, ceilings, and other out-of-sight building areas are the normal locations where hydronic system distribution piping is installed. The distribution system delivers the hot and or chilled heat transfer fluid to the thermal units and returns back to the equipment in the mechanical room. The distribution system's design is configured based on the building structure and the heating and cooling needs of the occupants. The four basic hydronic system distribution types are one-pipe systems, two-pipe systems, three-pipe systems, and four-pipe systems. Buildings with hydronic systems include hydronic piping plans within the complete set of construction plans. occupied building spaces or rooms containing the thermal units where heat is transferred to the room air. These thermal units may be either direct units installed in direct contact with the room air or indirect units that are installed in underfloors or in walls that heating or cooling room air indirectly. There are three main types of thermal units: radiant units, convection units, and forced convection units. This is the end of the Chapter 1 PowerPoint presentation. If there's any questions, please reach me on Blackboard or my email, and I will contact you back.